everyone. My name is Chi. Today I'm going to present EthStorage, building a modular storage layer on top of Ethereum. So a quick intro of myself. I've been working here for 6 years, primarily interested in infrastructure, especially layer 2 and data availability. So also closely working with Ethereum Foundation, receive a couple grants. So for EthStorage is also, and also today's talk is actually sponsored by the Ethereum Ecosystem Program. So what is EthStorage? It's basically another type of layer 2, but rather than scale Ethereum in terms of more transactions or more computation power, it aims to scale the Ethereum in terms of more space, more storage capacity, using the rollup approach. So compared to existing storage solutions, for example, famous ones like Filecoin, RV, we have a lot of unique features here. So first is minimum trust, which users just need to send a transaction to Ethereum and everything's done, rather than have to submit an individual transaction to maybe Filecoin or RV, and then submit the corresponding data hashes on chain. So everything here is minimize the trust that required by the users. Second is permissionless network, so everybody be able to run the corresponding data node and receive corresponding storage incentive from the network. And also, it is modular, so that we do not require any protocol upgrade of Ethereum. Thanks to ZK Snark, we are able to verify the off-chain storage, similar to the fraud proof and validity proof that to verify the execution result of off-chain, we have a storage proof that implement on top of Ethereum smart contract. And lastly, which is really important, is scalable, which we are able to achieve petabytes of capacity with 1 to the 1,000 transaction storage cost versus current Ethereum has. So first of all, how we are able to achieve minimum trust. So the key idea is that to use the latest EIP-4844 BLOBs that Ethereum just launched about 2 months ago, which dramatically reduced the core data cost to right now is almost negligible, with much higher capacity, with especially a lot of advanced technologies that is going to develop like PADS, which for the previous speech, that we are able to upload about 80 terabytes of data per year. So for the user, it just needs to send those EIP-4844 transactions to the Ethereum, where the transaction will call our storage contract and record corresponding blob hash, so that we know what kind of data the user would like to store. And then the rest of things will be automatically handled by the nodes in our storage network that we built dedicated for the Ethereum. So in this way, we are able to eliminate the centralized bridge. Basically, every node here will be incentivized to download the data from Ethereum and store a local version, broadcast to the peers, and then store this data and prove to the Ethereum saying that I really maintain a copy of data and receive corresponding reward from the Ethereum smart contract. So with this way, we are able to minimize the trust and also reduce the Ethereum security that is the major principle of Ethereum Layer 2. Second feature is that we are an open network with storage incentive alignment. So first of all, it's a permissionless peer-to-peer network by reusing, for example, libp2p, all these libraries, and so that we are able to accept the data from the peers. And everybody is able to join the network and become one of the nodes and be able to download the data and also send the data to others. And it has some key features to implement called storage incentive alignment. The main problem here is like Ethereum storage model is that all the storage fee, for example, paid by EthStorage OP or create contract, will be paid to the basically block proposer one time. So the block proposer receive all the storage fees, while all the full nodes running the as a validator, they will not be receive any fees, even though they run the full node or full replica of the Ethereum nodes. So in EthStorage, because we have so much data, then we need to have a better way to align the incentive between the users that pay the fee and then the corresponding data nodes. so that the user just pay one-time storage fee, which is similar as the current Ethereum model. And at the same time, this storage fee, when received and deposited in the smart contract, will gradually distribute to those data nodes that can prove that they really make a copy or replica of the data off-chain and receive the corresponding fee over time, so that we can align the storage contribution. That is number of that's the size of the data times the time, and then proportionally to their corresponding reward. And be able to verify their contribution, we need to also develop the on-chain storage verification so that we are able to distribute those fees proportionally to their contribution, that is the size and time over time. And to achieve that, we need every data node to prove their off-chain storage by sampling their local data. It's kind of like a peer DAS, but it's constantly sample this data over time, and then using Snark to compress those results, those procedures in a very, very simple proof, succinct proof. And once there's such a successful proof is being generated, then the data node is able to submit this proof to the network, or to the smart contract, and tell them, hey, I really stored this copy of data over this time. I would like to receive corresponding reward. And this Snark will be verified on chain using Eclipse proof pairing, and then we are able to check that the corresponding node is really maintaining the copy, so that and distribute corresponding reward. And lastly, it is scalable because we only need to have 2 EthStorage key value pairs that is on chain, so that we can maintain who owns the data and what is the data hashes of the corresponding 128 kilobytes blob. And so that we need 128 key value pairs that is stored on chain, but be able to be points to the 128 kilobytes of data, so that we can achieve 1000x. And assuming the Ethereum node capacity is about 1 terabyte, then we are able to achieve petabytes capacity, and that's how we get this number. Another common question asked us is that, what is your differences with existing systems like Filecoin and RV? So here I list gave a table, list the differences with different angles. Two things I would like to highlight is, first, EthStorage is working on kind of like offering like a key value programmable database thanks to the smart contract, so that we are allowed the users to use the smart contract to determine who owns the data, who is able to modify data, who is able to append data. While Filecoin RV, they are more designed for static files. So for example, in RV, there's no way to update a file, there's no way to delete the data, but in EthStorage, we are able to, thanks to smart contract, we are able to programmably to manage how the underlying key value database look like, where the value corresponding to 128 kilobytes of blob. And so this are able to enable a lot of applications, for example, decentralized social network, like we can have a blob, we can implement on top of EthStorage and Ethereum smart contract, we can have a lot of interesting applications that we give some examples later. And another major difference is that everything on top of EthStorage is built on top of Ethereum. It can use Ethereum wallet to send transaction and upload the data. It uses Ethereum account and also Ether as a storage fee. And also its development testing tool is all on top of Ethereum. So that we are not only be able to reuse Ethereum security, but also be able to reuse Ethereum development stack, Ethereum ecosystem. And this is really, really important that we are able to maximize the Ethereum, the value, at the same time, lower the friction of the new user to onboard using EthStorage. And so here is the roadmap of EthStorage. For last year, we received the grants, also secured the first place at Consumer Demo. And this year, so we have a couple of major milestones. One is that we have a public testnet that is now running on top of the Ethereum Sepolia testnet. And it has been running for 2 months. Everything is really quite stable. Definitely we welcome everybody to be able to join the network and try to crash, if you find some way to, hopefully, to crash this network in the early stage. So, and also, we have some proposals to, for example, integrate with Ethereum Proto Network and with the OP stack. So here is some dashboard and also the terminal of our public testnet. And it's on Sepolia, and we have about 100 replicas, with which most of the nodes are run by our third party, so that they are able to join the network, download the corresponding blobs, synchronize the data, and then do the periodic sampling, compress this proof, and collect corresponding reward. So feel free to go to our website. There's a link to tell you how to join the network and how to run this node in the network. And so with EthStorage, we are able to build a lot of new applications on top of Ethereum. One interesting application is that it can serve as a great Ethereum-aligned solutions to address data expiration issue of Ethereum. So right now, for Ethereum EIP-4844, it allows each block to carry 6 blobs, that is 6 times 128 kilobytes of data. Unfortunately, because it generates so much data, the Ethereum protocol specifies that this data is only saved in the Ethereum network for about 2 weeks. That means after about 18 days, all these Ethereum blobs will be discarded in the network. And EthStorage will be a natural way to help saving all this data using Ethereum-aligned approach. And this problem will become severe when the Ethereum is upgraded with, for example, PADS, which will eventually be able to accept about 80 terabytes of data per year on top of Ethereum network. And where to store this data is basically how EthStorage can work. And so these are some specification. For example, EIP-4844, that right now is about 18 days. And EIP-4844 is also going to remove some historical blocks that is older than 1 year. And so right now, the major users of Ethereum blobs are layer 2s, which they compress, batch their layer 2 transactions, and then submit to the Ethereum network, and using the blob as the way to carry all the data on top of Ethereum. So thanks to OP Stack, we also secure a grant to work using EthStorage so that we can able to secure all these layer 2 transactions in the blobs using EthStorage, so that when those data can be pruned, after pruning by the Ethereum protocol, they are also still available on top of EthStorage. And right now we have a test net that is testing all these features so that we are able to basically rerun, get the latest state of this layer 2 by running all the layer 2 transactions from Genesis to the latest state with part of data that is stored in the EthStorage, even though Ethereum has pruned all those data. And another interesting application is that we are able to combine with the computation power of Ethereum with storage power, so that we are able to enable a lot of fully on-chain applications. That's why we have proposed this Web3 access protocol, which I will give another talk tomorrow about the details. But in general, the idea is to turn the EVM as a decentralized HTTP server, so that now I can implement all those front-end logic in a smart contract and where the points to corresponding data on top of the EthStorage. So that now we are able to enable new type of applications with dynamic content that is managed, programmed by the smart contract. It's very similar to HTTP, but instead of calling a centralized IP address or DNS, it's basically calling a smart contract and tells, hey, I want to retrieve this data with this core data, and then this smart contract will return corresponding data. For example, we using EIP-4844 together with Web3 URL, we have been able to upload MFT images on top of Ethereum network, or even more powerful applications. For example, one application is we upload the whole Vitalik block that is about 104 megabytes of data, and then send all this data using EIP-4844 transaction to carry all these articles and send to a smart contract that is mapped by vitalik.block.eth, that is from ENS. And now we are able to upload the whole Vitalik's block that is now running in top of the Ethereum, rather than, for example, IPFS, which can discard the block at any time, because IPFS is not guaranteed the availability of the data. So this is really, really crazy ideas, but there are some more ideas that can build on top of EthStorage plus the smart contracts. Another interesting idea is fully on-chain AI, so that we are able to, for example, upload a large amount of the AI models or AI training data, and using, for example, smart contract to determine the quality of data, or to determine what is the relationship of the promote, that's the input of model, and the corresponding outputs. So, for example, for the on-chain inference, we could work with Aura on top of the called optimistic machine learning, so that we are able to almost instantly to tell what is the corresponding inputs or the outputs of a given AI model, so that now we are able to fully deploy this AI on top of blockchain without any third-party centralized parties. So this is all the talk today. So happy to answer any questions regarding EthStorage. Thank you very much.
Thank you so much. Are there any questions?
Hi, thanks, great talk. You mentioned the incentives, and then there's a one-time fee for storage. But how you kind of like make sure, like, or how you kind of distribute that over time, and how do you know frequency? Like, what if I would like to store something for 10 years, let's say, like not just like for a few weeks or a year, but like let's say 10 years. Can I like top up, or like how do you make sure that the incentives are still there for the nodes?
Yeah, that's a really great question. So basically, how we are able to cover a long time, maybe 10 years, or hopefully 100 years, or maybe 200 years, using one-time payment, because this is a bit counterintuitive versus our current fee model. And second is what is the interval, right? So for the distribution, we basically using a called discounted cash flow model, which means that when the user pay the first time of the fee, let's give an example, like 5% of the fee will be distributed in the first year. And for the next year, we will distribute the remaining of the fee and times another 5% and another 5%. The underlying assumption is that first, the storage fee will decrease versus the fee, and also the Ether price will be gradually, like according to our current observation, is going high. As long as this ratio is greater than 5%, then even basically the Ether will be basically paid to the storage providers, but the rest of fee can't be able to still be constantly cover the rest of the storage nodes in the following, while maintaining the same level of replications or security, because the security is 1 over n, where n is number of replicas. So this is the basic underlying assumption. Actually, this also applies to Bitcoin, because Bitcoin has assumption of having the block reward every 4 years, which implies that in order to secure the same security, the Bitcoin price must be double every 4 years, unless there's a significant amount increase of the transaction fee. So we basically employ the same model, but we implement all this model using smart contracts. So it automatically calculates the discounted flow and how much fee should be distributed in, for example, a second level calculation, but given the whole discount rate is 5% every year. So you can check out the smart contract, how we achieve that. So this is the answer for the first question. For the second question is regarding the interval. So the interval is a probabilistic process. And so for example, right now our design is I think 3 hours for the interval. The main reason for choosing such long interval is because we would like to amortize the fee over this 3 hours time, and also all the replicas in the network, so that the corresponding fee is able to cover the snark verification fee, because that will be expensive on top of Ethereum. So I think, let me see if there's if you go to our dashboard, you can see that there's a basic mining summary, tells how many blocks being mined and what is the corresponding reward versus the corresponding storage fee. At the verification fee that we would like to reach in some level of 1/10, so that the reward is about 10 times of the verification fee. That's how we choose the number. Yeah, that is really, really like important questions.
Awesome. Any other question?
I have a question about. I wonder what is your base data structure of the of your scheme, EthStorage. The data structure is still Merkle Patricia tree or Merkle tree or some other such as dynamic trees and so on.
That's great question. So actually, in the smart contract, the storage data structure is mainly backed by the Ethereum key value mapping by itself. We mainly maintain 2 mappings. One mapping is to give a list array of all the data hashes that the off-chain should store, like this. This is an array of data hashes. And second mapping is basically a way to tell who is the owner of these data hashes of this array, so that the owner is able to, for example, modify the data, or maybe remove the data, or maybe create new data. So there are 2 mapping that takes 2 key value pairs using as a store on top of Ethereum. So with these 2 mapping, now we are able to, for example, allow the applications to, using these key value interfaces, to modify the data, and at the same time be able to verify this list of array of data has been replicated in the off-chain network.
I mean that not layer 1 smart contract storage, but the layer 2 storage. So which data structure are you organizing the off-chain data? And the base data structure on which you generate a snark to prove the correctness of the data, prove the validity of the data. I mean the layer 2 data structure.
So for the layer 2, we are not like, for example, execution layer 2, which maintains its individual ledger. For the layer 2, you can imagine it just maintains an array of the blobs that is mapped the same after this array of the hash list that is on top of blockchain. So it's really simple. It just maintains an array of the blobs, which, for example, when there's a new data hashes that is append to this smart contract, and then all these nodes will download the corresponding data from the Ethereum DA network and append to their local storage. In this way, when they are performing the verification, they submit the proof, they are be able to verify it really matches the on-chain data hashes. So this is the current very simple design, but really powerful thanks to smart contract, because we can dynamically change this data using key value interfaces on our smart contract. So this is the how the data structure looks like.
I believe we do have time for one final question, if there is one. If not, thank you so much for joining us and sharing your insights with us.